Yes, good day, class. Today we are on mean deviation. When we went through the range, we realized that the range is not something that we can boast of too much. The reason is simply being that if you have data, say 2, I'll change this marker, 2, 3, 4, 5, 6. And you are to find a range. The range of this data is going to be 6 minus 2, which is 4. In the same way, if we have another data, which is say 2, 2, 2, 2, 2, 6. The range is also 6 minus 2, which is still 4. But the data is not the same. So now we had to look at a better way of trying to describe data. So let's move on to this new step, which is the mean deviation. What is the mean deviation? There is some foundation that we can lay so far as the mean deviation is concerned. What is that foundation? If, for example, we are talking about, let me say you are in Techimine. You are in Techimine. I think this marker is not helping. You are in Techimine. And you are traveling to Wenchi, or you are traveling to Akumadan. This is just an assumption. I have not actually checked the right distance between them. Let's assume that the distance between Techiman and Wenchi is 18 kilometers. And the distance between Techiman and Akumadan is also 18 kilometers. If Techiman is your point where you are, your base, moving to Wenchi, you are moving to the northern part of Ghana. Coming down to Akumadan, you are rather coming south. So in terms of direction, if the Wenchi is positive, the Akumadan is negative. If the Akumadan is positive, then the Wenchi is what? Negative direction. But when we are talking about distance travel, we don't look at whether it's negative or it is positive. So the distance from Techimine to Wenchi is the same as 18 kilometers. That's when you find magnitude of it, you will get 18 kilometers. Let me write it well. 18 kilometers. Whether it is positive or negative, the distance, when you find the magnitude, you get 18 kilometers. Let's assume that moving southwards is negative. So the distance between Techiman and Akumadan is 18 kilometers to the south. So I've indicated it by negative. But when you find the magnitude, you still get 18 kilometers. So it is the same thing that we are going to talk about. What is then the mean deviation? I want you to pay attention. If you have set of data, say x1, x1, x2, x3, x4, x5, and x6. And you have calculated the mean of it, x bar. Let's say the mean lies between this, in the middle of it. Let's assume that. Then, if we want to find the difference between x1, x bar, we are going to get x1 minus x bar. The difference between x2, x bar is going to be x2 minus x bar. The difference between x3, x bar is going to be x3 minus x bar. The difference between x4, x bar is going to be x4 minus S bar. For now, let me put comma. The difference between x5 S bar is going to be x5 minus X bar. And then the difference between S6 X bar is simply S6 minus X bar. Now, what is the mean deviation? The mean deviation just simply means the average distance between each data, each element in the given data and the calculated mean, and the calculated mean. So it means we want to know the average distance between each and the calculated mean. Note, if we subtract, looking at the data, S bar might be more than x1, x2, x3 in terms of magnitude. So when you subtract X bar from x1, you are going to get something like a negative. S bar from x2, you are going to likely to get negative. X bar from x3, you are likely to get a negative. But when you subtract the same S bar from S4, S5, S6, you are likely to get positive. In that case, if we sum them, that is, we put a plus in between. Let me use another color so that it will make it distinguish itself from what we have there. If we sum them, the positives and the negatives will be cancelling each other. So in effect, we might get an answer which is 0. And there is no way you can say that there hasn't been a distance between. So what happens is that we find absolutes of each difference, the absolutes of the differences that we had between the individual elements and the calculated mean. In that case, even if this is negative, it tends to be positive. But because we are talking about the average mean, it means we must divide their sum by the total number of elements concerned. So if we are talking about this, we are 1, 2, 3, 4, 5, 6. So the n could have been 6. This is how we find it. And we can simply summarize it as the mean deviation or MD to be equal to summation from the first element to the last element, the absolute of subtracting the mean from each of the elements and dividing the total by the total number of elements concerned. This gives us the formula for finding the mean deviation when you are given a set of data like this without frequencies attached. So we are coming to look at example, how we will solve example. By the way, I want you to have this in mind, the formula in mind, because we are going to look at it seriously. Suppose we have been given data like this: 2, 3, 4, 5, 7, 8, 9, 10. We need to find its mean, because the formula says that the mean deviation is summation from I equal 1 to n absolute xi minus x bar, where the x bar is the mean over n. Now look at it. The I start from 1, 2 up to n. That's the I could assume the number 1, the second, the third. That's the first element, the second element, up to the nth element. So if that's the case, we need to find the mean. How do we find the mean? The mean, we know the mean simply as summation I equal 1 to n of xi's over n, where I is equal to 1 to up to n. So if we are going to sum all these elements. Now let's look at it. This implies that the mean here can be calculated by summing this. When we sum all these 1, 2, 3, 4, 5, 6, 7, 8, we sum them. That's 2 plus 3, 5 plus 4, 9 plus 5, 14 plus 7, 21 plus 8, 29 plus 9, 38 plus 10, 48. Divided by, what is n? There are how many elements? 8 in all. So 8 we divide, we get what? 6. So the mean is 6. If that's the case, then let's try and see if we can calculate the mean deviation. In the mean deviation, we have our data, the xi's, which is 2, 3, 4, 5, 7, 8, 9, 10. Now, we need to find xi's minus x bar. As we are going to subtract the mean from each of them. So 2 minus 6 is going to be minus 4. 3 minus 6 is minus 3. Minus 2, 5 minus 6, minus 1, 7 minus 6, 1, 8 minus 6, 2, 9 minus 6, 3, 10 minus 6, 4. Because of the formula which is absolute, we must find absolute of the differences. So we have absolute of xi minus x bar. So each of them must be turned to a positive. So we have 4, 3, 2, 1, 1, 2, 3, 4. Summation of all of them. Let's sum them. 4 plus 3, 7, plus 2, 9, 10. The same thing down here. So we have 20. 20. So summation of xi minus x bar is summation of the absolute of xi minus x bar is 20. Therefore, the mean deviation is going to be summation of this is 20 divided by n, which is what? 8. Now let's look at 20 divided by 8. What do we get? We will get 2 points, because 8 goes into 22 times, remaining 4. So it becomes, when you divide the 0.4 by, you get what? 5. So dividing 20 by 8, we are going to get 2.5. And that becomes the mean deviation of the distribution of the set of data 2, 3, 4, 5, 8, 7, 8, 9, 10. That is how we calculate the mean deviation when data is given in this format. In the next setup, we are going to look at the mean deviation when it is ungrouped or when it is grouped as well. These are what we are going to look at. Thank you.